Okay guys, we are at 6-2. Permutations is the word of the day. This is a mathematical term that is used to refer to a type of counting that we're going to do in a second. And to get us started, here's the question. How many different passwords can I make using all of the letters in password? Okay, so password is an 8-letter word. How many different ways can I rearrange those letters so that a computer might recognize it as a password? Of course, you're not making a real word in a password, or at least you don't have to. Alright, so to get us started on this question, I'm going to ask you a simpler question. That is, how many different ways can I rearrange the 4 letters in the word math? Okay, I have to use each of the letters. I'm just rearranging them as if they're Scrabble tiles. Oh, well that's kind of handy, because guess what? I happen to have Scrabble tiles right here. Alright? So if I'm rearranging these, I can change them and put them in any order, but I can only use the letters once. Alright, that's a different word from this, and so on and so forth. So how many different passwords can I make by rearranging these letters? Alright, so come back to the board then. What I'm going to do is say, suppose I'm just filling in blanks. I've got 4 spots to fill in with the letters. In my first blank, I have any one of those 4 letters I can put in there. Alright, so I have 4 choices. Just like we're choosing meals at a restaurant or shoes for an outfit or whatever, I have 4 choices. But once I've chosen the M or the A or the T or the H, I then only have 3 choices remaining. Once I've chosen 2, I only have 2 choices. And when I've got 3 letters down, I only have 1 choice for that remaining one. I then multiply these all together. That's the multiplying principle of our counting that we learned yesterday. And I multiply those all together and I get 24 different passwords. Okay? Well, in math we're always looking for a symbol that sort of makes things simpler, and we use this symbol. Alright? That doesn't mean 4. That's not an exclamation point. That's called a factorial sign. Alright? So we would say that's 4 factorial. So, if I had 12 letters, the first 12 letters in the alphabet, and I'm going to make a 12-letter password, I would have 12 factorial different ways to rearrange those first 12 letters of the alphabet. And there's a way to do this in our calculator that's pretty handy, and I'll show it to you here. If you press the math button, okay, and you then go to the probability menu, so I would go over to PRB, that's probability, and then you can see option number 4 is the factorial symbol. Alright, so to use that then, I would type in 12 and then go math and then over to probability and hit 4, and there's the 12 with the factorial symbol. I just press enter and I will get the answer. Alright, so you can do a lot of these on the calculator. It turns out that is 479 million passwords, so it gets big quickly the more letters you add. Suppose though I have 12 letters available, but I'm only going to make a 5-letter password, because 12 is pretty long for a password. Then again, thinking like fill in the blank style, 1, 2, 3, 4, 5 blanks, I could fill in any one of 12 in the beginning, then 11, and then 10, and then 9, and then 8. That would be my 12 letters to choose from to make a password of 5 letters. Well, if you think about it, there's a mathematical way that I can write this using the factorial symbol. It's quite simple. I would just simply say, well, I want the 12 factorial, but I want to chop off the 7 times 6 times 5 times 4 that I don't need. And so I divide that by 7 factorial. Because again, if you think about stringing them all out, the 7 times 6 times 5 times 4, all of that is going to get chopped off by this 7 factorial, and all I'm left with is 12 down to 8 multiplying. So the way we write this using our mathematical symbols is NPR, and you'll see that in the book. That's permutation notation, and we can do this also in our calculator. I would type in the number 12, and then I go to my math menu, PRB, and then I choose this, and it'll say then NPR, and then I type in 5, because I'm choosing from 12 letters to make a 5-letter password. Okay? So 12 NPR 5, but you really would say that 12 P5. Okay? So going back to this original problem here with password, okay, I've got an 8-letter word, so the temptation is to write 8 factorial. However, there's a problem here that I've got a repeated letter. Okay, so again, I'm going to go to my Scrabble tiles to show this. Alright, hope that's not making your car sick. But if I make the word mirror, alright, I've got 3 repeated R's. So there's really no way of telling if I rearrange these and put these letters like that. I swap those R's. That's the same thing. The computer's going to recognize that as the word mirror, just like if I swap these around. Alright? That's the same password. Or finally, if I swap these around. Alright? How many different ways can I swap 3 R's around? Alright? Well, if you think about it, I could put any one of the 3 R's in the first R spot, and then I could put any of the 2 remaining R's there, but then the final R would have to go there. So that would be 3 choices times 2 choices times 1 choice. There are 6 different ways I can rearrange those R's, and the computer, or you or I, would not know. Alright? So when it comes to our password problem then, all we need to do is figure out how many repeats. There's S's there that are repeating, no other letter repeats, so I just do however many letters are repeating, 2 factorial like that, okay? And you can then find 8 factorial, and then 2 factorial is just 2, divide by 2. As a little side note, if you think about it, 2 factorial is equal to 2 times 1. 1 factorial is equal to 1. How about if you tell me what you think 0 factorial is? And then try typing it into your calculator and see if it is correct. Remember, this is really about counting things, and 0 factorial is a lot like saying how many different ways can I count 0? Alright? So, final question then is, how many different passwords can I make rearranging Mississippi? Alright? M-I-S-S-I-S-S-I-P-P-I. Alright? Why don't you figure that out? Count the number of letters, and then figure out how many repeats there are. Okay? There are going to be multiple letters repeating. And just as a side note, 2 factorial times 3 factorial is equal to 2 times 1 times 3 times 2 times 1. That's just 2 times 6. That's 12. It is not, repeat, not equal to 6 factorial, because that's equal to 6 times 5 times 4 times 3, and so on. And that is a much bigger number. Okay? So that's it. Tell me what is the answer for the number of passwords I can make for Mississippi. Thanks a lot.